Welcome to Demystifying Math. In this lesson, we're going to be discussing the horizontal transformations of the sine graph. Let's start off with the parent function y equals sine x. You should know that the sine graph has critical points at 0, pi over 2, pi, 3 pi over 2, and 2 pi. These are called critical points because they're going to be either the zeros of the graph, that is the x-intercepts, or they're going to be the high or low points on the graph. You should also know that the sine graph has a domain of all reals, a range from -1 to 1, a period of 2 pi, and an amplitude of 1. Now, recall that we got those critical points from the unit circle. Remember that the unit circle gives us ordered pairs. For instance, at 0 degrees, we have the ordered pair 1, 0, where 1 is going to represent your cosine and the 0 is going to represent the sine. So the sine of 0 is 0. The next critical point is also on an axis. This time it's on the y-axis, and that one is at pi over 2 and is giving us a high point. Then we go around to pi and we get a 0 again. And we go down to 3 pi, we're back to, in this case, a minimum point on our graph. What we want to do is be able to express all the x-intercepts in an equation. So we know that they are at -pi, -2 pi, -pi, 0 pi, and 2 pi. They're all pi units apart. So if you go back to your unit circle, we're at 0, pi, 2 pi, 3 pi, we're always going to get zeros for the sine. So since they're pi units apart, we could say, well, that's x equals pi n, where n is any integer. We also want to be able to express the maximum minimum points using an expression or an equation like that. So let's look to see where our maximum minimums are. We have a maximum at -3/2 pi, a minimum at -pi over 2, then we're back to a maximum point at pi over 2 and a minimum at 3 pi over 2. So again, these are going to be the ones that are on the y-axis on your unit circle. So they're pi units apart also. So what I like to do is start at the first one past 0, above 0, at pi over 2 in this case, and just add the distance between that one and the next one. So you would add pi to get to 3 pi over 2, and we could continually add pi and get more of these maximum minimum points. So your equation becomes pi over 2 plus pi n. Okay, so in this lesson what we wanted to do is concentrate on horizontal transformations. And with this problem we're going to start off with a period change, or a horizontal stretch, or shrink in this case. It's going to be a shrink. So we have y equals sine of 4x. And we want to compare it to the graph of sine x. So looking at our two graphs, the green one is sine, the blue one is sine 4x. Now, normally a sine graph has a period of 2 pi. But when I multiply the x value by 4, you can see that we have a lot more highs and lows and zeros between 0 and 2 pi than the previous graph. So let's see how many periods we have between 0 and 2 pi for the graph of sine 4x. So to get one period, we would go from 0 up, back to 0, down to a low, and then back to 0 again. So we have our two zeros, we have our maximum, and we have our minimum point. And we did all that in a length of pi over 2 units rather than 2 pi units. How many of those periods do we have between 0 and 2 pi on the graph of sine 4x? Well, let's go back and count them. So here we have 1, 2, 3. We actually have 4 periods between 0 and 2 pi. So the 4 is kind of telling us how many periods you have between 0 and 2 pi. So if we want to find the length of one period, all we have to do is take 2 pi and divide it by the coefficient of x, which in this case is 4, and simplify it down. So we have pi over 2, which is what we saw. Okay, so when your x value is multiplied by a number, and we're calling it b here, that's going to cause a horizontal stretch or shrink or a period change. If your b value, the absolute value of the b value, is between 0 and 1, it's going to cause the graph to stretch. Our b value is 4, so it's greater than 1, and it caused a shrink of the graph. A shrink meaning the whole graph is moved in closer to the y-axis. Okay, comparing these two graphs, they both still have a domain of all reals. They both still have a range between -1 and 1, and they both still have an amplitude of 1. So the only thing that's changed is the period. Okay, so if you change the period, you're also changing where your critical points are. So we need to find those 5 critical points within one period. So what we're going to do is take our period, which is pi over 2, and divide it into 4 equal intervals. Remember, on the parent graph, we had 4 intervals on between 0 and 2 pi where we had critical points. So we want to find those here as well. So we're going to take our period and divide it by 4 or multiply it by 1/4. So this means that every pi over 8 units, we're going to have a critical point on our graph. Our first critical point's at 0. If you shift your graph left or right, it won't be 0. But as long as you don't have a horizontal shift, your first critical point's going to be at 0. Then all we have to do is take that pi over 8 and continually add it to find more critical points. So 0 plus pi over 8 gives us pi over 8. Another pi over 8 is 2 pi over 8, 3 pi over 8, 4 pi over 8, and we've got 5 of them. So just put them in lowest terms. So you have 0 pi over 8, pi over 4, 3 pi over 8, and pi over 2 as your critical points. Now what you want to do is plug them into the function to get your ordered pairs. So if we plug in a 0 into sine of 4x, we're going to get 0. At pi over 8, remember you're multiplying by 4 first and then taking the sine. So we end up taking the sine of pi over 2, which we know is 1. If you follow this method, these critical points that you're getting are always going to get you back to a sine value that you know from the unit circle. Let's try pi over 4. Alright, with pi over 4, it simplifies down to sine of pi. Sine of pi is 0. Let's try 3 pi over 8. You end up with 3 pi over 2, sine of that, -1. At pi over 2, you get back to 2 pi, so your sine is 0. Okay, so now what you can do is plot your points and connect with a smooth curve. You might want to stop the video for a minute and do that, and then come back and check it. So you should have a graph that looks similar to this one. Check your work, make sure you did it right. Okay, so now what we want to do is look at where our zeros are. So we have zeros at negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, and so on. Now, I did more than one period here, but just keep following the same pattern and you'll get all those points. Now, what we want to do is generalize our zeros. So since our first one is at 0, and the distance between that one and the next is pi over 4, we would say 0 plus pi over 4n, but we don't need the 0. So it's just going to be pi over 4n. Let's also generalize the maximum minimum points. So we have them at negative pi over 8, positive pi over 8, 3 pi over 8, or you could say they're halfway in between your zeros. So if you ever forget where they are, just figure out what half the distance is between your two zeros. Okay, so let's start with the first one on the positive side of 0, which is pi over 8, and then figure out what the distance is between that one and the next one. So if you go from pi over 8 to 3 pi over 8, the difference is 2 pi over 8 or pi over 4. So we have pi over 8 plus pi over 4n. Okay, the other horizontal transformation that we wanted to discuss today is a phase shift or a horizontal shift, left or right. So we're looking at the equation sine of x plus pi over 4. In this case, we don't have any period change. So our coefficient of x is 1. So our phase shift is c over 1, or pi over 4 over 1, which is just going to be pi over 4. But looking at the two graphs here, the blue one is the sine, the purple one is the shifted one. Notice that it shifted to the left, not to the right. Now, whenever you're adding or subtracting from x, it's actually going to cause your graph to shift in the opposite direction of the sine. So keep that in mind as you go through. Okay, so we want to find the first critical point. Since we shifted the graph over pi over 4 units to the left, the point that was at 0, 0 on the sine graph is now shifted over to negative pi over 4 and 0. So that's going to be our new critical point. Then to find more critical points, we're going to do the same process we did before. We're going to find 1/4 of the period and continually add it to our starting point. Alright, so our starting point in this case is at negative pi over 4. So we're going to add pi over 2 to that. And our new critical point is going to be at pi over 4. Then we're just going to add pi over 2 again. And we get 3 pi over 4. Add another pi over 2 and we get 5 pi over 4. And our next one is 7 pi over 4. So I think you can see the pattern pretty easily on these. So once you get a couple of them, you know what the pattern is. So pi over 4, 3 pi over 4, 5 pi, 7 pi over 4. So adding 2 to the numerator. Easy to do that. Okay, so then you have to plug them into your function and get your outputs. Now, remember, these are going to be zeros, high points, or low points on your graph. So you should get your output going pretty easily as well. Okay, so now all you need to do is plot your points and connect with a smooth curve. Okay, so now you have them, and what you want to do is express your zeros. So looking at our zeros, we have some at negative pi over 4, 3 pi over 4, 7 pi over 4. So that's enough to get us an idea of where our zeros are. So we're going to start at our first 0 to the positive side of 0, which is 3 pi over 4, and add pi n to it. Now remember, from the very beginning, we always have 2 zeros within one period. So the period in this case is 2 pi, so we're going to have 2 of them. That means that they're going to occur every pi units, so plus pi n. You have maximum minimum points at pi over 4, 5 pi over 4, and the next one would have been at 9 pi over 4. And you can see the difference between them there. So you're starting with your first one, which is pi over 4, and you're adding pi n. Now again, you have a maximum point and a minimum point within one period. So there's 2 of those, one max, one min. So they're going to occur every pi units as well. Okay, we've seen a lot so far. In a previous video, we discussed the amplitude change. That's when your sine is multiplied by a number. And we also saw in this video a period change. So when x is multiplied by a number, it changes the period. So 2 pi divided by that number multiplied by x is going to give you a new period. We also saw in this video a phase shift, where we did a phase shift left or right. That's when x has something added or subtracted from it. So in the one that we saw, our b value is 1. But if there is a period change as well, just do c over b, that's going to give you a phase shift. And in the previous video, we also saw a vertical transformation of the graph where we're shifting up or down. And that's when the sine function has a number added or subtracted from it. In the next videos that we're going to see, we're going to have combinations of all these different transformations. So look for that. Thank you for tuning in.